Welcome to the JEE Main 2026 Whatever series. In that, we observe the functions, second part. Okay. In these functions, if you see the functions, second part, we observe the different types of functions. Now, in this session, we are extending the function. If you extend the function, we have a normal function f of x. Now, we are extending the function. Say, suppose I am taking f maps a into b is my function. A and b are two sets such that f of x is equal to y is my function. Okay. For all x belongs to a. Suppose this is my function. Then here x, if you take x is a superset of a. X is superset of a and y is also a superset of f of a. If x is superset of a, which implies that y is superset of f of a. Another function I am taking, that's why it can be called as extension. Okay. Another function g maps x into y we are taking. Okay. Such that g of x is equal to f of x. Okay. Then f of x, x belongs to a. Okay. Is called an extension of f from a to x. Is an extension of f, extension of f from a to x. Okay. So here what we have taken, in order to extend one function to another function, we have taken the supersets for those sets. Okay. X is superset of a, that is x is superset of a, which implies that y is superset of f of a. How the g will be with respect to this x and y? G is going to be the function between our x and y. Okay. So such that g of x is equal to f of x. X belongs to a and extension of f, a to x we can call. Okay. Yeah. In the same manner, we can observe the even and odd extensions of functions. Suppose I am taking f of x is a function. Okay. F of x be a function on a. Let me take like a is equal to 0 comma a closed interval. Okay. If I take like this, then x is equal to, what about the x? X is nothing but minus a comma plus a. This is superset of a. This is, sorry, superset. No? Superset of a. Okay. Superset of a. Then extension of f of x on x a to a is going to be, will be even or odd extent. Is going to be some, it may be either even or odd. If f of x, if f of x becomes an even function, then this is an even extension. If f of x is an odd function, it is going to be odd extension. Okay. Yes, very good. Let us take one example. Let me take one example like f of x is equal to something like x square plus 5x minus 2. Okay, this is my question. This is going to be defined on a 0 comma 2 closed interval. Okay. Mm. Then I want to find g of x. Let me take g of x is extension of f of x on a 0 comma 2. Okay. Extension on 0 comma 2, let me take. So how do we define? G of x is equal to f of x for all x belongs to a. G of x is equal to f of x for all x belongs to a. Let us now I am going to divide this x is equal to here, because you have taken minus 2 comma 2 I can take, or 2 to minus 2 comma 0. Okay. And 0 comma 2. These are the subintervals I have from 0 to 2 means. Okay. Mm. Say I am taking f of x is equal to, what is our function? X square plus 5x minus 2. I am finding f of minus x. Minus x whole square plus 5 into minus x minus 2. So what I get? This is x square minus 5x minus 2. Okay. So here you see even and odd functions I am going to take, right? So JEE of x I am taking. JEE of x is equal to f of x such that x belongs to 0 comma 2. Okay. X belongs to 0 comma 2, and similarly f of minus x, which implies x belongs to minus 2 comma 0. Okay, that is f of minus x is equal to f of x for every this is going to be even function, right? This is going to be even function for even 0 also, right? Even 0 also you are getting even function. And similarly I am taking odd function. Let me take in the same manner odd function. Let us take odd function g odd. Okay, g o of x I am taking odd function. This is odd function. G o of x is equal to f of x. X belongs to 0 comma 2. Okay, and similarly yeah minus f of minus x, right? Because it is odd function, no, minus f of minus x you will get, and then x belongs to minus 2 comma 0. Okay, so f of minus x is equal to minus f of x, so it is going to be an odd. Okay, so g of e of x is equal to ge of x is equal to x square plus 5x minus 2. X belongs to 0 comma 2, x belongs to minus 2 comma 0. In the same manner go of x also the same you are getting, but here minus x square. Let me take here GO of x, if I find minus x square plus 5x plus 2 such that x belongs to minus 2 comma 0. Am I right? Minus 2 comma 0. Whereas for the positive thing you will get the same value. X belongs to 0 comma 2. Okay. This is the difference we got. Got it? Very good. Let us observe the next question. One more question. Say, let me take f of x is equal to x square plus x tan x. X square plus x tan x. Then, so ge of x is going to be, it is going to be defined on 0 comma 2. Let us take, determine both even and odd functions of f of x on minus 2 comma 2. You have to find even and odd functions on this. So can I write like ge of x, gex is equal to even function x square plus x plus tan x, and it is going to be 0 less than or equal to x less than or equal to 2. Similarly, 0 between 0 and 2 we got, and between minus 2 and 0 also, no, x square minus x minus tan x. Okay, this is going to be minus 2 less than or equal to x less than 0. Less than 0. This is equal to g of x. Similarly, go of x, odd function, extension of odd function. So the same thing, x square plus tan x, and 0 less than or equal to x less than or equal to 2. And similarly, I want to get odd function, no? So minus of x square plus x plus tan x, and which is going to lie between minus 2 less than or equal to x less than 0. Okay. So this is going to be f of minus x minus f of minus x, and this is going to be f of x. That is ge of x is equal to f of x is equal to f of x positive, and f of x, f of minus x is equal to minus f of minus x. So it is going to be odd function. Okay, very good. In this way, we can solve the question. Let us observe some more questions. You see, A is equal to ABC, B is equal to PQR. Subsets of R. Okay, subsets of R. P less than 0, R less than 0, Q greater than 0. This is very important. Q greater than 0. Here, F is an ordered pair of A, comma P, B, comma Q, comma C, comma R. But what they are asking? They want root F. They want root F. Okay. P less than 0, root F not possible. R less than 0, not possible. So P and R ruled out. So only we are getting P, B and Q. Am I right? Only B and Q. So root F they are asking. Root F is equal to, how do I write? B comma, if you put B value, B, F is equal to B, then what do you get? F of X. F of X as B, X is B, then B, F, root F of X becomes root Q. Right? Yes. So B comma root Q you are getting. This is it. This is an order pair. Okay. Root F is equal to B comma root Q because these two are less than 0. Next, you see the fourth question. F and G are real valued functions defined by f of x is equal to 2x minus 1 and g of x is equal to x square. Then find 3f minus 2g of x. 3f minus 2g of x. Okay. What is the meaning? 3f minus 2g 3f minus 2g of x is nothing but 3 times f of x minus 2 times g of x. That is the meaning. Yes. You can easily calculate 3 times f of x. 3 times f of x. 3 times because our f of x is 2x minus 1. Okay. Minus 2 times g of x is x square. Okay. So what I get? So 3 2s are 6. 3 into 2x minus 1, 6x minus 3 minus 2x square. Okay. Finally, I am getting minus 2x square plus 6x minus 3 is my 3f minus 2g of x. Similarly, you find fg of x. Fg of x means f of x into g of x. Okay. This is you can easily find. Now you see root f by g of x, which is equal to, what is the meaning? Root of f of x by g of x. Okay. You know how to find root f of x? The same root 2x plus 1 by g of x is x square. Okay. In this way, you can easily find. Say next f plus g. This one. This is one important. F plus g plus 2. F plus g plus 2 of x, which is equal to, what is the meaning? F of x plus g of x plus 2. You substitute the values and you will get the answer. X square, that is 2x minus 1 plus x square minus 2. That is x square plus 2x minus 3. Will be the, plus 2, no? Sorry, plus 2 minus 1 is minus 1. So x square plus 2x, x square 2x minus 1. X square plus 2x, is it plus 1 or minus 1? Plus 2 plus 1, sorry. X square plus 2x plus 1 means I can write this as x plus 1 whole square. So this is our answer. Got it? Very good. Let us observe the next question. You see, f maps R into R is defined by f of x is equal to 1 minus x square by 1 plus x square. Then show that f of tan theta is equal to cos 2 theta. So simple. The same way, wherever your x, at that place you find, you just substitute those values, you will get the answer. That's it. Okay. This is my f of x. What they asked, f of tan theta. Wherever I find tan x, in that place I am going to put tan theta. That's it. Okay. By 1 plus tan square theta. What is 1 minus tan square theta by 1 plus tan square theta? That is cos 2 theta. Yes. How you got this one cos 2 theta? This is 1 minus tan square theta. This is sec square theta, no? 1 plus tan square theta is secant square theta. 1 by 1 by sec square theta is cos square theta. This is sine by cos into cos. Cos cancel, sin square theta. I am separating the denominator to both numerators. So tan square theta by secant square theta. This can be written as sin square by cos square theta. This is by cos secant square theta. Means it is going to be into cos square theta. Cos square theta minus sin square theta is cos 2 theta. Okay. So like this we can easily calculate. Next, y is equal to f of x. Y is equal to f of x, which is equal to x plus 2 by x minus 1. So that x is equal to f of y. Okay. Yes, x is equal to f of y. What is given? Y is equal to f of x is equal to x plus 2 by x minus 1. This is given. Okay. And x never be 1 and never be minus 2. Okay. They are asking x is equal to f of y. Can I find f of y? Wherever I find x, in that place I am going to put y. That's it. Okay. So y plus 2 by y minus 1. What is y here? Y is nothing but x plus 2. Just x plus 2 by x minus 1. Plus 2 divided by x plus 2 by x minus 1 plus minus 1. What I get? X plus 2. This is plus 2x minus 2 divided by x plus 2 minus x plus 1. Okay. Plus x minus x cancel. 2 plus 1. That is going to be 3. So in the numerator, plus 2 minus 2 cancel, 3x by 3, which is equal to x. Okay. In this way, we can easily solve these kind of questions just by knowing that wherever you find x in that place, that value, whatever the value is given, that value is going to keep inside that. You can easily get it. Let us look at the x. F of x is equal to sine log x, sine of log x. Then find f of xy. Wherever you find in that place, you put xy. Sine, what do you keep? Sine log x. Can I put sine, what they ask, f of xy plus something, no? Okay. Sine log xy. Okay. Let me find this similar way. F of x by y. Let me write the total thing. F of xy. F of xy minus plus f of xy plus f of xy minus 2 times f of x. Okay. F of xy is sine log xy plus this is going to be sine of log x by y, no? X by y you have to put for x. So what I would do? X by y minus 2 sine f of x. 2 sine log x. Okay? Log x. F of x into cos log y. Sorry. F of x into cos log y. Cos log y. Okay? Sine log x, sine log xy. Can I write this as sine of log x plus log y? Okay. Because log mn is log m plus log n. Similarly, sine of log x by y can be written as sine log x minus log y. Okay. Minus 2 sine log x, 2 sine log x into cos log y. Cos log y. Okay. Very good. What I do? Sine of log x plus log y. These are all sine. Okay. 2 sine. This is also sine. Log x plus log y. Can I write this as log x, 2 sine log x? This can be written as 2 sine log x into cos log y minus 2 sine log x into cos log y. Yes? Sine of log x plus log y. Sine of log x, sine of log x plus log y. Sine of log x minus log y. And minus 2 sine log x cos log y. So can I write this as sine of sine of log x plus log y, sine of log x minus log y. This is going to be sine a, sine of a plus b plus sine of a minus b. 2 sine a sine, 2 sine a cos b. Okay, 2 sine a cos b I got, and this the same thing, 2 sine a cos b. Those two will cancel, right? These two will cancel. You are getting 0. 2 sine of log x cos log y. Understand? So totally it becomes 0. Yes, let us look at the ninth question. F maps R into R, G maps R into R defined by f of x is equal to 2x square plus 3 and g of x is equal to 3x. Actually here 3x minus 2, it is missing. 3x minus 2. Now find f circle g of x and g circle f of x, f circle f of 0, g circle f circle, g circle, f circle f of 3. Okay. These are the things they asked to find. Very good. So let us observe f circle g of x. What is the meaning of f circle g of x? F circle g of x means f of g of x, right? F of g of x. Very good. So can I write this as g of x is given as 3x minus 2. F of 3 of x, 3x minus 2. Here, for our f of x is 2x square plus 3. So what I do, 2 into wherever I find x, I have to keep this 3x minus 2 in that place. Am I right? 3x minus 2 whole square plus 3. Got it? So 2 into 9x square plus 4 minus 2 to the 4, 4 3 is 12x. So f maps g, this one, we are finding f circle g of x, right? F circle g of x is equal to f of g of x. Here g of x is given as 2x. G of x is given as 3x minus 2. Okay. F of 3x minus 2. Let me find. And f of 3x minus 2 means f of x is given as 2 into 2x square plus 3. Okay. Let me write that. So 2 into x. Instead of x, I have to put this one now. 2x square plus 3. So 2 into this is 9x square plus 4 minus 2 3 is a 6, 6 2 is a 12x plus 3. Okay. That means, not for this. So 2 into 9x square plus 12x, 9x square minus 12x. That is, can I directly multiply? 18x square minus 24x, 4 plus, here 4 2s are 8, 8 plus 3 is 11. Okay, plus 11. This will be the answer. Okay, got it? Yes. Next question. So if this is f circle g of x, g circle f of x is also in the same manner. G of f of x you can find. Okay, g of f of x is given as 2x square plus 3. But g of x is here 3x minus 2. So 2 into, no, here g of x is 3x minus 2. So 3 into 2x square plus 3 minus 2. Okay, that is 6x square plus 9 minus 2. 6x square plus 7. This will be the g circle f of x. G circle f of x. G of f of x. Okay, very good. Next, f circle f of x. F circle f of 0. 0 they are asking, which is equal to f circle f of 0, right? F of 0. F of, first let us find f of 0. Hmm. F of x is 2x square plus 3. So 2 into 0 plus 3, which is equal to f of 3. Can you find f of 3 again? So f of 3 is going to be 2 into 3 square plus 3. That is 2 into 9 plus 3, 18 plus 3, that is 21. Okay. In this manner, we can easily calculate all the things. G circle, F circle, F of 3. This is also in the same manner. So G circle, F circle, F of 3. So G of, how do you write this? Let me write first. Which is equal to G of F of 3. Okay. Yes. So G of F of 3. F of 3 is how much? 2 into 3, 9, 8, 21, right? Again, F of 21 is 21 into 2, 42. 42 plus 3, 21. Okay, 45. So G of 45, I am thinking. Let me find G of 45. G of X is how much? 3x minus 2. So 3 into 45 minus 2. 45 G of F of 21. Wait, 1 second, I will do again. G of, let me write that. One step. G of F of 21. Okay. Now, what do I get? G of F of 21. F of 21 means F of 2 into 21 square, right? Sorry. 21 square is 441. 441 plus 3. 882 plus 3, 885. That means G of 885 you have to find. Okay. G of 885 is 3x minus 2. 3 into 885 minus 2. 3 5 is 15, 3 8 is 24, 25 to 3 8 is 24, 3 5 is 15, 3 8 is 24, 25 to 3 8 is 24, 26 minus 2. So 2653. 2653 is our answer. In this manner, we can easily calculate all the things. Very good. Let us go to the next one. Look at the next question. F of x is equal to kx by x plus 1, x not equal to minus 1. Given that f circle f of x is equal to x, it is given. What is given? You see, sorry, f circle f of x, right, clearly. F circle f of x is equal to x. This is given, okay? F circle f of x is equal to, so can I write this as f of x? F of x is kx by x plus 1. This total thing is again equal to x, which is given f of kx by k plus 1. So instead of x, what I have to keep again? k into kx by x plus 1 whole divided by kx by x plus 1 plus 1, which is equal to x. Okay. What do I get then? Then k square x is equal to x into ax plus x plus 1. Okay. What I get? So k square x cancelled. What I'm getting? No. K square x I can take common, no? In all. If I take x as common, k square minus kx minus x minus 1, which is equal to 0. If I take common, x into k square minus kx minus x minus 1 is equal to 0. Right. So you see here, this is x into a k square minus kx minus x minus 1. It's no doubt k square minus 1 into minus x into k plus 1, which is equal to 0. Yes, correct. So this is going to be x into, this is k square minus 1 means k plus 1 into k minus 1. So can I take k plus 1 as common? X into k plus 1, if I take common, here k minus 1 is left and x into k plus 1 gone. So minus 1 is left. Any doubt? x into k plus 1, if I take common, x minus 1 gone. X is left, sorry, not 1. Okay. X into k plus 1, x into k plus 1 into k minus 1 minus x. Okay. What they asked here, k value. K is equal to k plus 1 is equal to 0. Either k plus 1 is 0 or k minus 1, something in terms of x we are getting. So k is equal to minus 1 we got, no? Yeah, k value only they asked. Okay. In this manner, we can easily solve it. Okay. Yes. Let us look at the next question. That is 11th question. That is f of x is equal to sin x. G of x is equal to 2x. G of x is equal to 2x. H of x is equal to cos x. Show that f circle G is equal to G circle FH. Okay. Yes. This is, you see. What I do is f of x is equal to sin x. Hmm? Next, g of x is equal to g of x is 2x and h of x is this much. F circle g of x, which is equal to f of g of x. F of, what is g of x? G of x is 2x, no? 2x. F of 2x, which is equal to, I can write it as sine 2x. Okay. And G circle, what about the next one? G circle FH of x. This can be written as G of f of x into h of x. F of x, h of x. G of f of x, h of x. So what do I write? G of, I can write it as f of x is sin x. G of x, h of x is cos x. What about g of x? G of x is my, where is g of x? G of x is my, where is it? 2x. Okay. G of x is 2x. So can I write it as 2 sin x cos x? Okay. This is nothing but 2 sin x cos x is sin 2x. Okay. Sin 2x. So this is sin 2x and this is sin 2x. They asked to show these two are equal. Yeah, we got these two are equal. Okay. Very good. Let us observe the next question. 12th question. Determine whether the function f of x is equal to a power x minus a power minus x plus sin x is even or odd. So even or odd means what is the condition for even and odd? F of x is equal to f of minus x even. If f of x is equal to minus f of minus x, and then it is odd. This is odd, this is even. Okay, let us check. F of x is given. Our f of x is equal to a power x minus f of x is equal to a power x minus a power minus x. I am finding f of minus x. F of minus x means what it is going to be? A power minus x, okay, minus a power minus of minus x becomes positive, okay, plus one more term I forgot, plus sin x, plus sine of minus x. Sine of minus x is minus sin x. Can I write directly? Minus sin x. Okay. So f of minus x and f of x both are not same. Yes. So these are not same means f is an odd function, I can say. Right? F is an odd function. Okay. Right. Next. Why f of x and f of minus x are not same? And we have to show one more important, not equal means f of minus f of x is equal to minus f of minus x you have to show, no, sorry. Let us find that, let us show that. So can I take here, I can take minus common, yes. If I take minus common, I am getting minus a power minus x, okay, plus a power x plus sin x. You see, this is our f of, this is f of minus x, right? This is our f of x. You check a power x minus a power minus x plus sin x. So this is going to be our f of x. So f of minus x is equal to minus f of minus x. Okay, f of minus x is equal to minus f of x. F of minus x, what I'm writing? F of minus x is equal to minus f of x. This is odd function, sorry. What I said? F of x is equal to, if it is f of minus x directly, then it is even function. F of x is equal to minus f of minus x, then it is going to be odd function. Okay, it is an odd function. Very good. Let us observe the next question, 13th one. F of x is equal to this much as sum of even and odd function. Express the function as sum of even and odd. Let me take f of x is given as 2x power 4 minus 3x square plus 6x plus 7 minus 4 sin x. Okay. Can I take, I have to split this, right? If I take the first three terms as one group and the last two as one group, no, because it is going to be minus. It's not possible. So 2x is, otherwise I will arrange these 2x power 4 minus 3x square plus 7. I am taking it as one group. And this is one group. And what is left? 6x minus 6x minus 4 sin x. This is another group I am taking. Okay. If I make the groups like this, you see, because these two are positive. So you can get easily even function. Okay. For this, with respect to this first expression, first part, I am getting even function, and no doubt this is going to be an odd function. Okay. This is an even function. This is an odd function. Why? If you take minus x, f of minus x also, you are getting this, all are even power, so you are getting positive only, the same thing you will get. But this is, if you take minus 6 into minus x, minus 6x, minus 4 into sine of minus x is going to be minus sine x, that is plus sine x you are getting. So f of minus x is not equal to, is not, f of minus x is equal to, I can take minus common here, then I am getting minus 4 sin x plus 6x. Okay, f of minus x is equal to minus f of x. Okay, got it? F of minus x is equal to minus f of x. It's an odd function. F of minus x is equal to positive f of x only, then it is going to be even function. Got it? Very good. Next, look at the last question. F maps or into R, G maps or into R are even and odd functions respectively. Even and odd functions respectively. Prove that Fg is an odd function. F maps are into R, G maps are into R. This is even, this is odd. Okay. Even function means f of minus x is equal to f of x. Okay, first part. And similarly, odd function means g of minus x is equal to minus g of x. Okay, right. What they said? Prove that fg is an odd function. F into g. Okay, f into g of minus x I am taking, which is going to be f of minus x into g of minus x. This we know. You see, f of minus x is our f of x. Okay, g of minus x is minus g of x. What do you get? Minus fg of x. Yes, minus fg of x. Okay, minus fg of x. Fg bracket here. Minus fg of x. You got this as an odd function. Fg of minus x. Fg of minus x is going to be minus fg of x. So it is an odd function. That is f of minus x is going to be minus f of x, then it is going to be odd function. Don't confuse. Before I said in different way. Okay. F of minus x is equal to minus f of x, then it is going to be odd function. F of minus x is equal to f of x, it is going to be an even function. Got it? Very good. Let us observe the different types of functions. Okay. When we have different functions, we already observed the different types of functions. But in addition to that, in this extension of functions, and the main classification is this. Okay, that is one-to-one function or injective function, or you can call it as injection. Okay, you are calling it as injection. What is an one-to-one function? Let me take, for example, I am taking one example. A and B two sets. A, B are two sets. X, Y, Z, and take L, M, N, P, and Q. Okay, like this I'm taking. Say here I am making X with P. Okay, and Y with L. Like this. I'm making a relation. And Z with Q. Okay, is it a function or not? Yeah, definitely it is a function because each and every element of A has its unique image in B. It's a function. Very good. So you can see here if A is equal to XYZ, B is equal to LMNPQ. Okay. Then how do I define F? F I am defining. Okay, A to B. F maps A to B can be defined as injective. Why it is injective means I can write F as XC is related with P. XP is my first order pair. Okay. Then Y L is second order pair and Z is with Q. Okay. You see, in this distinct elements have distinct elements of A have their distinct images, right? In B. Okay. Very good. So can you find the domain and range now? So what is the domain here? Domain is going to be XYZ and range is going to be LPQ. Right? Domain is XYZ and range is, what is range? L, P and Q. Okay, L, P, Q. So suppose I am taking f of x is equal to, so this can be, if you see this is only unique element, it is making a connection with unique element in B. Okay, every element is making unique element in B. So this kind of function can be called as what I say, injective function. Okay, if you want to define in a distinct elements, like in elemental form, suppose first let me define normal way, then I will go with the elements. Okay, by taking general elements. F maps A into a function, F maps A into B is such that distinct elements in A, right? Distinct elements in A have distinct images in B. Distinct images in B. Then that function can be called as one-to-one or injection function. Okay? That is, say, I am taking two elements, A1 and A2. A1 and A2 belongs to A. Here A1 and A1 should not be equal to A2, right? Both should be different, distinct, I said. A1 should not be equal to A2. That implies that f of A1 is not equal to f of A2. Are you agreeing? Yes. So, or you can say, if f of A1 is equal to f of A2, then A1 is equal to A2. Okay? A1 is equal to A2. Say, if A1 is equal to A2, what is the meaning? F of A1 is equal to f of A1. What is the meaning? If A1 is equal to A2 means f of A1 is equal to f of A1 is equal to f of A2. A2 is also A1. F of A1 it is. So it is, we can't call this as an injection. This does not give F maps A into B an injection, right? Okay. This is not the meaning that it is not an injection. Got it? Okay. And one more important point is, suppose A and B I have taken in before case, I took that is A and B are two finite sets, right? Here I took A and B finite sets. Okay. Right. If I took finite sets, F maps A into B is going to be 1 to 1. You see, N of A should be less than or equal to N of B. Am I right? N of A should be less than or equal to N of B. It may equal, but it should be less than also. Okay? N of B. And suppose N of A is equal to P I am taking. Number of elements in set A is P. And number of elements in set B is going to be Q. Then how many functions it is going to make? Okay, let us observe. So how many functions from A to B it is making? If you want to check this, actually you have a formula. If you there is a derivation to derive this, but I am saying directly the formula. Number of one to one functions between A and B, between A and B, A is having P elements and B is having Q elements, is fact Q factorial by Q minus P factorial. What is that? Q factorial by Q minus P factorial. Okay. How many one-to-one functions here? You take for this example. Here, one-to-one functions in this case. Okay. In this case, one-to-one functions 3. Factorial Q. Factorial Q. That is here 2, no? 2 by 1, 2, 3, 4, 5. N of B is Q, no? 1, 2, 3, 4, 5. Total 5. 5. I can write it as factorial 5 by 5 minus 3. That is 2 factorial. So 5 into 4 into 3 into 2 factorial. Number of one-to-one functions. Okay. In this manner, we can calculate. Okay. Yes. Next question. So F maps, I am taking f of x is equal to one example, 2x plus 7. You see, for all x belongs to z, let me take. For all x belongs to z, I want to, f maps z into z. Okay. F map z into z defined by f of x is equal to 2x plus 7 for all x belongs to z. Is it one to one or not? We have to check. Is it one to one or not? Yeah, definitely it is one to one, right? Definitely it is because you are giving one value of x, you are getting different value for y. One image for distinct images, for distinct values, you are getting distinct values of f of x. Okay. Say I am taking one more example. F of x is equal to x square. Come on, you check this. Here, f maps R into R. I am taking f of x is equal to x square. For all x belongs to R. Let me take like that. Is it one to one? Say it is not one to one. What is the reason? If I take f of 1 is equal to 1 square, which is 1, and f of minus 1 I am taking. This is also minus 1 whole square is equal to 1. So it is showing for 1 and minus 1, it is having only 1 is the image. Right? For both elements of A, it is showing the same image. If it shows same image, it is not one to one, right? It's not 1 to 1 because f of 1 and f of minus 1 both are same you are getting. It's not 1 to 1 function. Got it? Very good. Let us observe the next one. So one-to-one injection definition, one-to-one is injection if f of x1 is equal to f of x2, then x1 is equal to x2. Okay. This means no two different elements in no two different elements in domain map to the same element in codomain. They should not map. Just like before we observed, 1 and minus 1 both map to 1. That's why it is not injection. Okay. Graphical representation passes the horizontal line. If it passes the horizontal line test, a horizontal line should intersect the graph at most once. Okay. So you see, for example, f of x is equal to 2x plus 3 is a linear function with a non-zero slope. With a non-zero slope. It is an exponential function. It is a cubic function. Okay. So f of x is equal to x square is not an injective. F of 2, f of minus 2. We took it before 1 and minus 1 we took. Any number you can take because it's you are getting positive value. So it's not a injection. Okay. Got it? Very good. Let us observe them. Whenever we deal with graphs at that time, I will tell how to test it. Okay. At that time. Let us observe the onto or surjective function. Surjective function or surjection. Okay. If you see the definition, if you take a function from f maps a into b is onto, if every element of b has at least, every element of b has at least one pre-image in a, one pre-image in the domain or a. Okay. So then a is called an onto function or surjective function. Other words, you can say if f maps a into b is called surjection, if the range of f is equal to the codomain of f, can I say range of f is equal to the codomain of f? Yes, is it correct? Definitely. Okay. Yes. Next, you see covers the entire range. Why codomain is equal to range? It is going to cover the entire range, right? Right. Okay. Next, you see, suppose I am taking for each, say, one element, generalize, I will generalize it. Say, for each element B belongs to B, A and B, no, two sets, there exists, small a belongs to capital A such that f of A should be equal to B. You understand? F of A should be equal to B. Then F maps A into B is a surjection. So B for each B belongs to B, there exists small a belongs to A, F of A becomes B, then F maps A into B is a surjection. If A and B, suppose I am taking A and B finite, what happens? A and B are finite sets. Then F maps A into B, if you observe, is a no doubt surjection, correct? It is onto. But what about the N of A and N of B? Think it. N of A should be greater than or equal to N of B. Am I right? Yes. N of A should be greater than or equal to N of B in the case of surjection. Okay. Whereas you see in the case of one-to-one function, N of A is less than or equal to N of B. Right? N of A, number of elements in A less than or equal to number of elements in B in the case of one-to-one. Okay. Whereas here n of a greater than or equal to n of b. This is very important. Okay. And one more important point regarding to this is if it is going to be a surjection or onto, the range equal to the codomain. I already told the range is equal to the codomain. This is very important point. That is, f maps A into B is onto f of A should be equal to f of capital A should be equal to B. Okay, got it? Now we will find the number of what I say. How many number of surjections we are getting if you take if you consider the two two sets. If n of A is equal to m, I am taking n of B is equal to 2. Okay, then what are the number of possible onto functions? Number of possible onto functions onto functions from A to B I am finding. Okay. Onto functions from A to B, it is going to be 2 power m minus 2. Okay. 2 power m minus 2. If n of A contains m elements and n of B contains 2 elements, then 2 power m minus 2 is the number of onto functions from A to B. Okay. One more important point, if F maps A into B is not onto, suppose it is not onto means it can be called as into. If it is not onto, it can be called as into. Okay. Yes. What is into function? We will observe later. Let me take one example now. Mm, say this is my A and B. A is containing A, B, C, D. B is containing, let us take X, Y, Z. Okay. What I do is A is making with Z. Okay. B is Y. B is with Y. And C with X. And C, let me take C is also with Y. And D is with X. Okay. Is it onto function? Is it onto function? This C is going with Y and B is also going with Y. D is going with X. Okay. So range of F. What is range of F here? Range of F is X, Y, Z. And codomain is also the same. Codomain, which is codomain of F. Right? Okay. Range is equal to codomain. Range is equal to codomain. So it is onto function. Got it? Very good. Next, I am taking f maps n into n. Let me take f of n is equal to something like 2n plus 3. F maps n into n I am taking. Is it onto or not? Let me check. Say n is f is n to n means you can go with 1, 2, 3. Those values you can give for this one. Okay. So 2 into 1 plus 3, that is 5. 2 into 2, that is 7. 5, 7, 9, so on you will get. Right? Which is not equal to n, right? Which is not equal to n. So the codomain is not equal to the range. Am I right? Codomain of F is not equal to the range. That's why this is not onto. You understand? Whenever the codomain is equal to the range, then you can say that it is onto. Okay, this is not onto. Why? Because you are getting 5, 7, 9. 1 to 4 we are not getting. 1 to 4 you are not getting. So n means 1, 2, 3, 4, so on like that. Hmm? Yes. Let me take another example. What I take? Let me take f of x is equal to 2x plus 2. This is my question. For this, f maps q into q I am taking. Okay. Is it surjection? That is it surjection or onto both are same? Is it onto? Let us check. Let me check the pre-image. Pre-image of y. What is the pre-image of y? Y minus 3 by 2. Okay, which belongs to Q. Am I right? So this is domain. This is domain. And for all values of y belongs to Q. That is codomain. This is codomain. So is it surjection? Yeah, definitely is surjection because you see any pre-image of y, any pre-image of y, that is y minus 3 by 2 belongs to Q. Okay, got it? Yes. Let us go with that is, what is the total meaning of this onto or surjection? That is, if F maps A into B is onto, then to each value of B, small b belongs to B, at least one element, at least you can have more also, at least one element A such that A belongs to A, such that F of A should be equal to B. F of A should be equal to B. Next. Okay, got it. Onto function or subjective or subjection. Next, one to one and onto both. If both are going to be happen, then that function can be called as both conditions are satisfied. It can be called as bisection. So bisection one to one and onto function. So I want to define the bisection. A function F maps A into B is bisective if it is both one-to-one and onto. This implies that there is a perfect one-to-one correspondence between domain and codomain. Am I right? Perfect correspondence. Otherwise, it may not. Okay. Let us take one example. This is XYZ, and the next one is 1, 2, 3. X3, Y1, 2Z. Let me take like, okay. Mm. You see here, XYZ XYZ, what are the what is the F, what are the ordered pairs we are getting? X comma 3, Y comma 1, next Z comma 2. Okay, these are the ordered pairs. So you see, what is the meaning? A and B are finite sets, no doubt. Yes, A and B are finite sets. That is the first point. Yes, and if F maps A into B is a bisection, when it is a bisection, n of A should be equal to n of B. When it is going to be bisection, n of A, these two are finite sets, n of A is going to be equal to n of B. And one more important point, identity function, you take any identity function. Identity function on set A, which is going to be non-empty, it is going to be a bisection. Okay, identity function on a non-empty set is going to be a bisection. And suppose I am taking A and B are two finite sets, right? N of A is equal to N of B. We have taken. Then how many number of bisections are going to define between A and B? Let us check. You see here, N of A factorial. What is that? N of A, number of mappings or number of bisective functions. Number of bisective functions which are defined from A to B are N of A factorial. A constant function? Yeah, definitely. A constant function is going to be a bisection if when what is the condition? N of A should be equal to N of B, right? Constant function becomes a bisective function only N of A is equal to N of B, which is 1. Okay. And identity function on non-empty set, on non-empty set A is a bisection. Okay. Constant function and identity function, that makes the difference in the case of a bisection. Got it? Okay. Let us take one more example. like what I say. Here also horizontal test, pass both horizontal test and covers the entire range. Okay, it covers the entire range. We will observe whenever we deal with graph at that time we will check or we will see that graphs in detail. Okay, right. So for example, I am taking f maps R into R. Let me take f of x is some x square plus 4. What about the range? The range is going because R no, so no doubt range is going to be 4 comma infinite, right? 4 comma infinite. Very good. X square should be greater than or equal to 0. Why? X square should be greater than or equal to 0 and x square plus 4 greater than or equal to 4. Okay. So, and it is not equal to the codomain, right? And it is not equal to the codomain R. Hence, it is not a, we can say it is not a surjection. Okay. That means if you take any particular case like if there are no pre-images for all real numbers less than 4, okay, less than 4 in its codomain R. So, and also note that this is going to be not an injection, not an injection. Okay, got it? X square plus 4 and the range is going to be 4 comma infinite. Then you can say that here it is not a surjection, no doubt. Okay, and if you take any particular case, if there are no pre-images for all real numbers less than 4, there are no real numbers, it is saying, right? Starting from it is starting from 4, less than 4 no images means, so it is not an injection. Okay, because it is not considering the values of from 1 to 4, 1 to 3. Hmm? That is the meaning. Okay, and some more important theorems which are based on this are, suppose I am taking like f maps A into B and G maps B into C. Okay, two functions I am taking. Then I am taking G circle f maps A into C is also one to one. That means the composition of two one to one functions is also, this is one to one. This is also one to one. Then composition is also one to one. Okay. This is one important point. You make a note of it. And the second point is I am taking two onto functions. Okay. Let me write here itself. I am taking f maps A into B is onto. Okay. And this also B into C is also onto function. Then G circle F composition of 2 is also onto. Okay. This is also possible. Next, the other thing is, let me take the other bisection now. What happens in the case of bisection? Whether it is satisfying or not. A into B and G B into C are two bisection. This is bisection. This is also bisection. Okay. G circle F is also bisection. That is composition of two bisections is also a bisection. Composition of two bisections is also a bisection. Okay. And one more important thing, like say one important point I have to say. F maps A into B and G maps B into C. I am taking two functions like this. Okay. Then G circle F maps A into C is 1 to 1. When if it is 1 to 1, then F maps A into B is necessarily 1 to 1. Is necessarily 1 to 1. Okay. Similarly, G circle, this is the same condition. G circle F maps A into C is onto, then F maps A into B is necessarily onto. Yes, got it? Is necessarily onto. Hmm? Okay, these are the two main important points. And also one more thing, F maps A into B, G maps B into C, I am taking, are two functions. Okay. Then G circle F, A into C is 1 to 1. Then F maps A into B is 1 to 1. G maps B into C need not be 1 to 1. You understand? G circle F maps A into C is 1 to 1. Then F maps A into B is 1 to 1. And G maps B into C need not be 1 to 1. Need not be 1 to 1. G circle F, the other in the case of onto I am observing. G circle F maps A into C is onto, okay, which implies that then G maps B into C is onto. Okay, G maps B into C is onto. But F maps B in A into B, F maps A into B need not onto. You got the difference? This, in this case, whenever this is the, what do you say, composition of two functions is going to be 1 to 1, then F maps A into B is 1 to 1, but G maps B into C need not 1 to 1. Okay. And here the reverse, B into C is onto, F maps A into B need not onto. Okay. Let us take one example and we will observe. Say, let me take one example. This is AB, or the two sets. C, no, three sets we need, because this is F and this is G. Okay. 1, 2, 3. PQRS ABC. Let us take. ABC. Take. So 1 to P, okay, and P to C. I'm taking. Next, 2 to Q to A. 3 to R to B. Let me take like that. If I take like this, and S to C also, one more you add. Yes, very good. Now you see G circle, G circle F, G circle F, that is A into C. I am observing. A into C is 1 to 1, right? N of A is equal to N of B, and they have all the things possible. And F maps A into B, F maps A into B is 1 to 1, but G maps B into C is not 1 to 1, right? G maps A in B into C is not 1 to 1. This is not 1 to 1. Why? P has, this is not 1 to 1. This is not 1 to 1. Okay. So G circle F A into C. Let me draw that G circle F. And then, so the remaining part I'm drawing here. A and C. If I draw, then it will be clear for 1, 2, 3 ABs. Let me try it. 1 C, 2 to what I have taken, 2 to A, and 3 to B. Like this I took. Okay. You see, G circle F A into C is onto. It is onto or not? G circle F, this is. G circle F, this one. What is that? This is going to be G circle F. Okay. G circle F. G circle F is going to be onto. But F maps A into B is not onto. Okay. F maps A into B, this is not onto. You see, yes, this is not onto, right? This is not onto. In onto, what is the condition in onto? Onto f of a, n of a should be greater than or equal to n of b. So f maps a into b is not onto here. Okay, f maps a into b is not onto. You understand? Very good. Now this is b into c. So G circle. What is the, from this example we can say f maps a into b, G maps b into c. If you take two functions, G circle F maps A into C is 1 to 1, 1 to 1. F maps A into B is 1 to 1. The other may not. B into C may not. Need not. Okay. And G circle F A into C is on to. But the second thing, B into C should be on to. A into B may need not be on to. You understand? So this is the meaning of this. Okay. Got it? Very good. Let us observe the next type of thing, inverse function. Next. Now, many to function. After that, we will go to inverse. Many to function means F maps A into B many to one. If two or more elements in the domain map to the same element in the codomain. Okay. That is called many to one. Okay. Got it? Yes. Next, inverse of a function. If f maps A into B is a function, then you can take, just you have to reverse the ordered pair. B comma A you have to take. Generally A comma B you are taking. A comma B belongs to F. Okay. If you take this as an ordered pair, is called the inverse of F. It is denoted by F inverse. Okay. F inverse. For example, A is equal to 1, 2, 3. A is equal to 1, 2, 3 I am taking. Similarly, B is equal to something like A, B, C. Then F is equal to 1C. F is 1C, 2B, 3A. Is a bisection from A into B. F is a bisection, right? 1 to 1 and it is on to. It's a bisection. So F inverse it is going to be A3, B2 and C1. Okay. This is F inverse. Is it bisection then? Yeah, it is a bisection from B to A. You understand? No doubt it is a bisection from B to A, but it is going to be. Understand? Very good. Say, let me take A is equal to 1, 2, 3, B is equal to A, B, C, D. I am adding one more here. Then you observe whether it is a, what I say, inverse function or not. See, I am taking A is equal to 1, 2, 3, B is A, B, C, D, then F is going to be 1C, 2B, 3A. F is going to 1, 3, okay. And it is 1 to 1. It is an injection, okay. No doubt it is an injection, but not surjection. But not surjection from A to B. Why? F inverse you take. F inverse if I take, what I am getting? F inverse if I take A1, A3, no, I took before. A3, 3 to A I took, right? 3 is to A and 2 is to B, 2 is to B and 1 to A, 1 to C I took, okay? A comma 3 and 2 comma B, 1 comma C. Sorry, B comma 2 and C comma 1. I will get like this. This is the ordered pair. But you see D is left. It is not a function, right? In the first, if you go with minus F inverse means A, B, C, D from B to A, right? B to A. 1, 2, 3. A to 3, B to 2, C to 1. C to 1. Let us take like this is not any kind of, this is not having any mapping. Okay. So it is only the relation, it is not a function. You understand? So That means you can say it's a relation, it's not a function. Say F maps A into B is an injection, and then inverse relation is a bisection from F of A to A. Okay. If you take F maps A into B is a bisection, then inverse relation is also a bisection. Inverse relation is also a bisection. And similarly, you can go with like F here they took F of F inverse Y is equal to Y for all Y belongs to B. F inverse of F of X is equal to X for all X belongs to B, like that they took. Okay. Right. Next, if F is a bisection, if and only if there exists a function, say I am taking F maps A into B is a function, then F is bisection if and only if there exists G maps B into A such that how it should be G circle F is equal to IA identity. F circle G is equal to IB. Understand? IB. And as in the case, you see G is equal to F inverse. Okay, this is very important. And one more important point, F maps A into B, okay, and G maps B into C, you take, are two bijective functions, then G circle F inverse is equal to F inverse circle G inverse. Okay, F inverse circle G inverse. This is very important. Okay, so these are the important points related to the inverse function. Okay, very good. Okay, these are the inverse functions, and in the next session we will see the periodic function and all. Okay, thanks for watching. Bye bye.